Polar alignment on an equatorially mounted telescope makes it possible to counteract the Earth's rotation by turning the RA axis only. Then, by definition, you will be able to track a star driving the RA motor at a constant rate, and it can remain in the eyepiece for long periods. Then, on an intelligent drive system with coordinate readouts, the handset can accurately perform go-tos with minimal error. Only one calibration point is necessary to synchronize the handset coordinates with the star frame. Polar alignment is achieved by finding the error in the polar axis pointing and compensating by physically adjusting the altitude and azimuth pointing of the polar axis. On the AWR PEM mount, the adjustments are on the adjuster base as indicated. Loosen off enough to allow the metal to slide. Here is a closer view for the azimuth adjusts and the spanners placed on. There are many methods of finding the error in the polar axis pointing. This can be the traditional drift method by the eye, or speeded up using a video camera, or here by plate solving the star region around the pole using SharpCap Pro for analysis. Another similar modern method is the Polemaster equipment, which includes the camera. Here the camera comprises a 135mm lens and an adapter to attach the webcam type camera. Matt's video has SharpCap Pro running. There is a wizard that guides you through the procedure. The basis of the method with SharpCap Pro is to take an image of the polar region, drive the RA axis through 90 degrees and take another image. Plate solving is done at both positions and the alignment errors calculated. The software itself leads you through the steps. You carry out the adjustments live and it tells you when you have completed the altitude and azimuth adjustments. To get the most accurate result, you need to do or have done the following. 1. The telescope should have properly been balanced beforehand. Flimsy mounts and tripods can bend if the centre of gravity shifts. This upsets the polar alignment. 2. If you have slipping clutches, do not be tempted to use them and pull the telescope round. You can induce forces in the assembly that are not normally present and so upset the polar alignment. 3. Drive the telescope with the RA motor in between the two positions required by SharpCap Pro. 4. Make sure the camera cannot slip if using a camera. 5. Use a crosshair eyepiece at high power if you are doing a visual method. 6. No touching of the mount at all during this process. 7. Do up any fixing bolts gently, trying not to disturb polar alignment. 8. Finally, check the result using the same method and by a different method. This will confirm the result. Proof of the pudding is also in the using, but go-to accuracy is only partly based on correct polar alignment. Other little errors, some mechanical, all conspire against you. This discussion is for another time. The final step shown here is adjustment, and this is facilitated in the Pro version of SharpCap with a live update on the adjustments required. So you can do the mechanical adjustments within a few minutes, do up the locking bolts, and check it is still aligned. And there it is done. You still need to check it by several methods, but you can start using it with a single point calibration and trying go-tos. It is suggested you try short length go-tos until you are familiar with the sequence involved.